Here we are, quarter one, week 4, day 4. We are using order of operations to solve. All right, well, we know once again we are talking about PEMDAS. P-E-M-D-A-S. P stands for parentheses. E is exponents, multiplication and division as a group, and addition and subtraction as a group. So, let's go ahead and solve this. We have to do parentheses first. So 21 divided by 7 is 3. So we have 3 plus 6 plus 3 to the third power. Okay, so then we are done with parentheses. Now we need to see if there anything that has exponents. Well, we do have the 3 to the third power. That is not 3 times 3. It is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So it's 3 plus 6 plus 27. All right, so we're done with exponents. There is no multiplication and division. We're down to addition only. So basically we have 3 plus 6, which is 9. 9 plus 27 is 36. Following order of operations, the answer is 36. Okay, let's find this quotient. All right, how many times does 15 go into 4? It doesn't. How many times does 15 go into 43? Well, it can go into it 2 times. 15 times 2 is 30. So we're going to subtract that. 43 minus 30 is 13. We're going to bring down that 7. So we have 137. How many times does 15 go into 137? I think it's a pretty big number. We can get a lot of 15s into that. So 9 times 5 is 45. 9 times 1 is 9, plus 4 more is 13. Yeah, that worked out pretty well. 7 minus 5 is 2, and then we bring down the 8, 28. All right, so how many times does 15 go into 28? Only one time, because 15 times 2 is 30, so it's just 15. So 28 minus 15 is 13. And now we're going to have to bring down a 0. Okay, so how many times does 15 go into 130? Once again, it's going to be a nice amount, but 135 was what we got before when we did the 9. So it's going to be one below that, I would have to say, probably the 8. So 5 times 8 is 40. 8 times 1 is 8, plus 4 more is 12. That's 10. Bring down another 0. So how many times does 15 go into 100? It's not 8. I'm going to say 6 probably is what we would have to do here. Let's just check. 6 times 5 is 30. 6 times 1 is 6, plus 3 more is 9. And then it's going to be a 10. And then we're going to have to bring down another 0. Okay, well, it's going to do this again. It's going to keep happening over and over and over, where we're just going to keep having the same number appear. So we're going to stop right there, bring the decimal up. We have 291.86 with a line over it, or 291.87, because the next number after it would be a 6, which is 5 or above. Those would be good answers to find this quotient. All right, so here we are. We're going to find the quotient of fractions this time. So we are dividing, and we know that when we are dividing, we have to do a process called keep, change, flip, where we keep this, change that to multiplication, and flip this or find its reciprocal. All right, so we have 4 over 5 times 7 over 3. All right, let's see if we can cross-reduce anything from here to here. Nope. Can we cross-reduce anything from 5 to 7? Nope, we're just stuck with what we have. 7 times 4 is 28. 5 times 3 is 15. All right, so we have an improper fraction. We know that we can take 115 out of 28, so that's going to be our whole number. 28 minus 15 is 13 left over. 28 minus 15 is 13. So 13 out of 15. So 1 and 13/15 would be the quotient for these two fractions. All right, here we are again. Find the quotient. We're going quotient crazy today. They've got several of them. All right, so let's go ahead and do this one quick. Does 12 go into 5? Nope, it doesn't. Does 12 go into 54? I would say it would go into it 4 times. 12 times 4 is 48. Okay, so 48 to 50 is 2, and another 4, so it's going to be 6 here. And we're going to bring down the 3. How many times does 12 go into 63? I would have to say probably 5 times. 5 times 12, 2 times 5 is 10. 5 times 1 is 5, plus 1 more is 6. So subtracting that, we're going to end up with 3, bringing down the 4. All right, so how many times does 12 go into 34? It can't go into it 3 times, that's 36. So 12 times 2 is 24. And that makes it 10. We have to put a 0 here. Bring down the 0. 100. How many times does 12 go into 100? I'd say 8 times would probably be a good one. Let's see. 8 times 2 is 16. 8 times 1 is 8, plus 1 more is 9. Yeah. So 100 minus 96 is 4. Bring down another 0. How many times does 12 go into 40? 3 times, because I know 12 times 3 is 36. That's going to be a 4. Bring down the 0. And 12 goes into 40 3 times again. All right, you guys can probably see what's going to happen now. It's going to continue on and on forever. So the answer for this one would be perfectly fine to make it, let's see if we bring the decimal up there, 452.83 with a line over it, or just 452.83 without a line over it, because the next number is 3. So it's not going to make the 3 go into a 4. So either one of those would be perfectly fine for that answer. Okay, we're finding the product of two numbers that are decimals. So we have to write it this way. Do we have to line up the decimals? No, we do not. It is multiplication. It is, if it's addition or subtraction, we have to line up the decimals. All right, so let's change colors and make it easier. 9 times 4 is 36. 9 times 2 is 18. Plus 3 more is 21. 9 times 1 is 9. Plus 2 more is 11. 9 times 3 is 27. Plus 1 more, which is 28. Okay, then put the space there, because we're done with this one. Let's do the 3. 3 times 4 is 12, so we're carrying the 1. Put the 2 there. 3 times 2 is 6, plus 1 more, which is 7. 3 times 1 is just 3. And 3 times 3 is 9. Then we add these up. 6 plus nothing is 6. 2 plus 1 is 3. 7 plus 1 is 8. 8 plus 3 is 11. 9 plus 1 is 10. Plus 2 more is 12. Okay, so at this point we have 1, 2, 1, 8, 3, 6. So now we have to look at the decimals up here. So how many numbers are to the right of these decimals? Well, there's going to be 1, 2, 3 numbers. There's 3 numbers there. So we'll go over 1, 2, 3 places. So the answer to this is 121.836. 121.836 is the product. Okay, so they are having us find the quotient again today. So I guess the main thing I want to find out or point out again, okay, repetition is good, is that we do have two numbers that have decimals in them, and we are trying to divide them, and that's never a good thing. So we want to take this number, which is the divisor, and make it a non-decimal. So we're going to move it over one place or multiply it by 10. So this becomes a 26. And then we have to do the same thing to this side, which would make it 243.1. Okay, so I guess the main thing I want you guys to have written down on this one is change this so that the number, or this number out here, which is the divisor, and this is the dividend in here, but the divisor does not have a decimal. Okay, so I'm going to go ahead and put in the answer here for you just so you have it down and you can kind of work it out at a future time. But the answer is 9.35. So I already worked it all out. I just want you to jot that down. But the main thing I want you to do, since we've already practiced quotients a couple times, is make sure you change the 2.6 into 26, and then 24.31 you change to 243.1, and that's what's written on your paper. All right, let's go on to the next one. Okay, guys, we got a little story problem here. It says a red string of holiday lights blink once every 3 seconds, while a string of blue lights blinks once every 4 seconds. So we have 3 seconds and 4 seconds. So basically, if we look, if we kind of find the multiples of 3, 3, 6, 9, and 12, and then 4, it's 4, 8, 12. Well, if we're finding the greatest common factor, least common multiple, if we're finding the least common multiple of the two, it's 12. Okay, which means every 12 seconds, the lights are going to blink at exactly the same time. Now, the other in between those 12 seconds, they're going to kind of blink interspersed and not at the same time. But how many times does 12 go into 60 seconds? Well, the answer is 5 times. Okay, so on 5 different occasions in that minute, both the red lights and the blue lights are going to blink at exactly the same time. Other than that, they are not going to be blinking at the same time. Angie baked 100 cookies and 20 brownies. She wants to split them into equal groups for the bake sale. Each group must have the same number of cookies and brownies, with none left over. What is the greatest number of groups she can make? Well, we're going to have to find the greatest common factor, or what is the biggest number that can both go into 20 and 100? Well, without doing a whole bunch of work, I can tell you right now, I know that 20 goes into 20 one time, and 20 goes into 100 5 times. So basically, what we're trying to find is the greatest common factor, which we did. The biggest number that goes into both is 20, which means each group is going to have 1 brownie. Okay, and then 20 goes into 100 5 times, and they're going to have 5 cookies. Let's just put a C there. So they're going to have 1 brownie and 5 cookies. And if we do that, then they're going to have 20 different groups, right? And because each group is going to get 1 brownie, and each group is going to get 5 cookies. So what is the greatest number of groups she can make? 20 groups, and there will be no brownies or cookies left over, just like we're looking for. All right, to make hummingbird nectar, you must use 4 cups of water and 1 cup of sugar. So 4 cups of water and 1 cup of sugar. Instead, it's what is the ratio of water? So they said water first, so we have to do that, to sugar. So they said sugar second. So the amount of water is 4 cups. So it's going to be 4. And we can put colon, I guess. And then sugar's second, so that'd be 1. So there's our ratio, 4 to 1. Okay, but we can also write it a couple different ways. 4 to 1 with the word 2, and 4 over 1. All of those would be perfectly fine in this scenario to show the ratio.